Welcome students on online class for the subject physics. Today we have learned about chapter number 5, oscillation. In this chapter we have seen some examples to determine the kinetic energy, potential energy and total energy of simple harmonic motion. So today we have seen first important formulae. Displacement of mean position or displacement of particle from mean position is x will be a sine of omega t, whereas displacement of particle performing simple harmonic motion from extreme position is x extreme, here x mean is equal to a cos of omega t. The first formula. Second formula will be omega is equal to 2 pi upon capital T, or omega equal to 2 pi frequency. These two formulas about omega. Then we want to know k upon m is also omega square, or k is equal to m omega square. Another formula which can be seen, that is about velocity. So velocity will be omega in square root of amplitude square minus displacement from mean square, whereas velocity maximum it will be a omega. Another formula will be seen, and then we can see kinetic energy of particle performing linear simple harmonic motion will be half m omega square in bracket a square minus x square, whereas kinetic energy of particle performing mean position at performing simple harmonic motion at mean position, it will be half m omega square a square, because x is 0 for mean position. And kinetic energy for extreme position, see here, kinetic energy for mean position and kinetic energy for extreme position will be 0, because x equal to a, so a square minus a square becomes 0. Another formula will be potential energy. So potential energy of a particle performing linear simple harmonic motion will be half kx square, or half m omega square x square. At mean position, potential energy will be 0, whereas at extreme position, if x equal to a, will be half m omega square a square. Similarly, we know that total energy. So total energy of particle performing linear simple harmonic motion will be kinetic energy plus potential energy of particle performing linear simple harmonic motion. So total energy at mean position, at extreme position or at any position will be half m omega square a square, which is constant. The energy will be conserved, which shows that law of conservation of energy. Using this formula, so first we want to solve an example. That example will be a particle of mass 0.05 kilogram performs linear simple harmonic motion. Its displacement from its mean position will be x equal to 0.1 sine pi upon 4 into t. Find potential energy, find kinetic energy, and find total energy at 0.05 meter. So first we want to find, or we want to note a data that will be m is equal to 0.05 kg, and here displacement at mean position is given. So we know at mean position x is equal to a sine of omega t. Compare the equation with above equation. So amplitude A will be 0.1. Here omega in meter. Omega will be pi upon 4 into t, or omega t will be pi upon 4 into t. So omega equal to pi upon 4. And here potential energy, kinetic energy, total energy at means x is equal to 0.05 meter. So today we have to find first about m omega square. So here m will be 0.05 into omega will be pi upon 4 bracket square, which will be written as 0.05 into pi square upon 4 square will be 16. So m omega square will be 0.05 multiplied by 3.142 multiplied by 3.142 and divided by 16. So here we want to note by using logarithm. Bar 2 point, 0 point, 0 point, numerator addition will be there. So first we want to see about log of 50. So log of 50 will be 6990. Here 31 in 4, 2 is mean difference, that is 4972. Here 4972. Addition will be 4, 9, 9, 9, 27 and 2, 29. 2 is there, and 16 bar 1. So if we see 16, its characteristic will be 1 point, and so that its log will be 2041. If we subtract, so what happen? 3 will be remaining, 9 will be remaining, 1 is here, and 8 is remaining, 4 will be remaining, bar 2. If we see antilog, so antilog of 0.48 in 9, 3 will be mean difference. So 48 in 9, it is 3.083. In 3, mean difference is 2. So it will be m omega square will be 3.085 into 10 to the power minus 2. So here we know for finding potential energy has formula. Potential energy of particle will be half kx square, it will be half m omega square x square. If we substitute the values, becomes half multiplied by 3.085 into 10 to the power minus 2 into 0.05 bracket square. So what happened? 2 on the 2, 2 on the 2 point. 1 is remaining 10, 2 5 the 10, 2 4 the 8, 2 2 the 4 and 2 5 the 10. So it is 1.5425 multiplied by 10 to the power minus 2 into 0.0025. By shifting the decimal point here, we can see 1.5425 into 10 to the power minus 2 into 25 into 10 to the power minus 4. So minus 4 and minus 2 will be minus 6. So here 1.5425 into 25 into 10 to the power minus 6. So if we multiply 25 into 5, that is 125, 12 will be remaining, 25 into 2 50 and 12, 62 is there, 6 is remaining, 25 into 100, 106, it will be 106, 10 is remaining, 25 into 5, it will be 125 and 10, 135, 13 will be remaining, 25 into 1, 25 and 13, it will be 38. So here 1, 2, 3, 4, 1, 2, 3, 4. So 38.5625 into 10 raised to minus 6. So here potential energy will be 3.85625 into 10 to the power minus 5 joule. It will be potential energy. Again, we can find out the kinetic energy. Second thing, kinetic energy is equal to half m omega square in bracket a square minus x square. So here half, we know m omega square will be 3.085 into 10 raised to minus 2 in bracket a will be 0.1, 0.1 bracket square minus 0.05 bracket square bracket. Again, kinetic energy will be 1.5425 because 2 on the 2 and there 1.5425 into 10 to the power minus 2 square bracket. It will be 0.01 minus 0.0025. If we can subtract 0.0100 minus 0.0025, its subtraction will be 75,000. So here 1.5425 into 10 to the power minus 2 in bracket 0.0075. So we can written as 1.425 into 10 to the power minus 2 into 75 into 10 to the power minus 4. So here if we take logarithm, so log of 1542, here 0 point is there and 75 1 point is there, addition. So if we see 15 in 4 and 2 is in mean difference, its log will be 1881. If we see log of 75, it will be 8751. So addition will be 2, 13, 16, 10, 1. 1 and 1, 2. If we take anti-log of 0.6 in 3, 2 is in mean difference. So antilog of 0.6 in 3 and 2 is mean difference will be 1.157 into 10 to the power 2 into 10 to the power minus 6. So here kinetic energy will be 1.157 into 10 to the power minus 4 joule. Here potential energy will be 10 to the power minus 5, kinetic energy will be 10 to the power minus 4. Multiplication. Again, the third will be total energy. If we can find out total energy, so total energy equal to kinetic energy plus potential energy. If we substitute the values, so values will be 1.157 into 10 to the power minus 4 plus 3.856 into 10 to the power minus 5. By shifting the decimal point, so 10 raised to minus 4 will be common. So it is 1.157 plus 0.3856 in bracket into 10 to the power minus 4. Their addition will be 6, 5 and 7 will be 12, 1 is remaining, 8 and 1 will be 9 and 0, 10, 1 is remaining, 3, here 6, 12, 1, 3 and here 1.1570 and 0.3856. Its addition will be 6, 12, 14, 5, 1. So into 10 to the power minus 4. So answer will be total energy will be 1.5426 into 10 to the power minus 4 joule. It will be the answer for first example. Again, if we can solve the second example. A body of mass 0.1 kg performs linear simple harmonic motion. Its displacement from mean position x equal to 0.1 sin of pi t in meter. After 1/6 second, find kinetic energy, potential energy and total energy. These numerical will be same. In this numerical, we have write a data. Here mass will be 0.1 kg and here by comparing displacement from mean position, it will be x equal to a sin of omega t. So here by comparing, omega becomes pi, but t is given, so t is equal to 1/6 second. If we can substitute 1/6, so 0.1 sin of pi multiplied by 1/6. Here a will be 0.1 meter and we can find out kinetic energy, potential energy, total energy. Similarly, here x is also determined. X is equal to question mark. See, it will be 0.1 sin of 180 divided by 6. So it is sin 30. So x is equal to 0.1 multiplied by 1/2 and displacement will be 0.05 meter. If we substitute the values for potential energy, first potential energy is equal to half kx square. So first we want to find k equal to m omega square. M is 0.1 multiplied by omega will be pi square. It will be 0.1 into pi square. So it is 0.1 into 3.142 into 3.142. By seeing the log of 0.1, it will be bar 1.0000. Here 0.4972, 0.4972. Addition 4, 14, 19, 9, bar 1. If we take antilog for 99 in 4, so that in 99 in 4 its antilog will be 9863, and in 4 mean difference will be 9, so 63 and 772, so 9872. K is equal to 9.872 into 10 to the power minus 1. Here if we substitute the values, half multiplied by 9.872 into 10 to the power minus 1 in bracket 0.05 bracket square, it will be 4, because 2 4 the 8, 2 9 the 18, 2 3 the 6, and 2 6 the 12. So 4.936 into 10 to the power minus 1 into 25 into 10 to the power minus 4. So multiply here 5 6 the 25 6 the 150, 15 is remaining. 25 3 the 75 and 15, it will be 90. 9 is remaining. 25 into 9, it will be 225 and 9, 234. 23 is remaining, and 25 into 400, 123. So 123, 12.133.400 into 10 to the power minus 5. If we shift the point here, it is 1.234 into 10 to the power minus 4 joule. That is potential energy. Here if we see the potential energy, minus 5, 1, 2, it will be 3, minus 3. So kinetic energy will be, kinetic energy is equal to half m omega square in bracket a square minus x square. Substituting the value of m omega square, it is 1 upon 2 multiplied by 9.872 into 10 to the power minus 1 in bracket 0.1 square minus 0.05 square. Again, if we divide, it is 4.936. So kinetic energy will be 4.936 into 10 raised to minus 1 in bracket 0.0100 minus 0.0025. If we subtract here, it will be 4.936 into 10 raised to minus 1 multiplied by 75 into 10 raised to minus 4. Again, if we see log 0.1 point, if log of 49 in 3, 6 is in mean difference, will be 6928, and in 6 will be 5, so 6933. Again, if we see 75, it will be 8751. Add 4, 8, 16, 15, 2 point. If we take its antilog of 0.86 in 8, mean difference 4. 56 in 8. So 56 in 8 will be 3698. And in 4, 3 is mean difference. So it will be 3.701 into 10 to the power 2 into 10 to the power minus 1 into 10 to the power minus 4. So here kinetic energy will be 3.701 into 10 to the power minus 3 joule. Again, potential energy is 10 raised to minus 3, multiply here, and in kinetic energy 10 raised to minus 3, multiply there. So we can find out total energy. So total energy, it will be summation of kinetic energy and potential energy, means 3.701 multiplied by 10 raised to minus 3 plus 1.234 into 10 raised to minus 3. 10 raised to minus 3 get common. So yeah, so that 3.701 plus 1.234 into 10 to the power minus 3. So it answer will be 5394. 4.935 into 10 to the power minus 3 joule. That is the answer for given example. So again, if example like such example is given, a particle of mass 0.05 kg performs simple harmonic motion of amplitude 0.1 meter and period 6.28 seconds. Determine its kinetic energy and potential energy when it is 0.08 meter from its mean position. See that here data is given. Data will be mass is 0.05 kg. Amplitude is 0.1 meter. Time period is 6.28 meter. And we can find out kinetic energy, potential energy, and displacement from mean position will be 0.08 meter. So first, here time period is given. So by using formula T equal to 2 pi upon omega, we can find out omega equal to 2 pi upon time period. So 2 into 3.142 upon 6.28. Again, if we multiply, omega becomes 6.28 divided by 6.28, get cancel, it is 1. So omega will be 1. Mass is there, so we can find out m omega square will be 0.05 multiplied by 1, that is 0.05. That will be the value of K. So here number 1, if we can determine kinetic energy. So kinetic energy will be half m omega square in bracket a square minus x square. So here half multiplied by 0.05 in bracket 0.1 bracket square minus 0.08 bracket square. Again, here it will be 0.025. So 25 into 10 raised to minus 3. 1, 2, 3. Decimal point is shifted. In bracket, it will be 0.0100 minus 0.0064. If we subtract, so it becomes 25 into 10 raised to minus 3 multiplied by 36 into 10 raised to minus 4. So here if we can see logarithm of 25, logarithm of 36 means characteristics will be 1 point. So 25 in 0 it is 3979. 36 in 0 will be 5563. By adding 12, 14, 15, 9, 2 point. Take its antilog. So antilog of 0.95 in 4. 0.95 in 4, 8995, and 2 is mean difference 4. It will be 8.999 into 10 raised to minus 7 into 10 raised to 2. So here answer will be, kinetic energy will be 8.999 into 10 raised to minus 5 joule. Answer will be in joule. So here again we can find out potential energy. So potential energy is equal to half kx square, that is half m omega square x square. It will be half into 0.05 in bracket x will be 0.08 bracket square. Here if we can write 5 into 10 raised to minus 2, here 64 into 10 raised to minus 4 divided by 2. So 2 divides, it becomes 32. So 32 multiplied by 5. 32 multiplied by 5 into 10 raised to minus 6. It is 5 to the 0, 1 is remaining, 5, 3 the 15 and 1 16 into 10 raised to minus 6. So it is 1.6 into 10 raised to minus 4 joule. So the answer for this question, it will be 1.6 into 10 raised to minus 4 joule. This is the answer for given question. Again, if an object of mass 50 gram performs simple harmonic motion of amplitude 8 cm and period 5 seconds, calculate its energy. Here we can calculate its energy. What will be the kinetic energy at 5 cm from its mean position? See here, its energy means kinetic energy at mean position at 5 cm from mean position. So data will be, mass is given as 50 gram, amplitude is given as 8 cm, period is given as 5 seconds. Kinetic energy will be calculated if x is given as 5 cm. All terms are in CGS system. So here first of all we can find out omega equal to 2 pi upon capital T. So 2 into 3.142 divided by 5. So it is 4826 point divided by 5. 5 on the 5, 5 on the 5 point. 12 is there, 5 to the 12, 28 is there, 5 the 25, 3 is there, 34. So 5 6 the 30 and 5 8 the 40. So omega will be 1.25 0.068. But here we can find out m omega square. So, or we can find out kinetic energy. So kinetic energy is equal to half m omega square in bracket a square minus x square. By substituting the value, it will be half mass is multiplied by 50. Here omega is 1.2568 bracket square. A will be 8 centimeter and x will be 5 centimeter. So here if we can solve, it is 25. So 25 multiplied by 1.2568 multiplied by 1.2568 multiplied by 64 minus 25. So here we can see that 25 multiplied by 1.2568 multiplied by 1.2568 multiplied by 39. If we can see the log, so log of 1 point, 0 point, 0 point and 1 point. So their addition. So 25 in 0, its log will be 3979. 12 in 5, 0969. And in 6, mean difference 6 will be 17. 17 means 7 is added, it becomes 78 is there, and 10, 88. So 0988. 0988 and 39, it will be 5911. So 9, 9, 18, 8, 26. 2 is there. 9, 11, 19 and 7, 26. 2 is there. 9 into 4, 36 and 2, 38. 3 is there. 3 and 3, 6 and 11 and 3 is there. If we can find out its antilog of 0.18, 0.18 in 6 will be 1.535 and in 6 mean difference it will be 2. So kinetic energy will be 1.537 into 10 raised to 3 joule. So its kinetic energy will be 1.537 joule. Question will be, an object of mass 0.4 kg executes simple harmonic motion of amplitude 10 centimeter. If potential energy in extreme position is 1.97 into 10 raised to minus 2 joule, calculate period of S.H.M. So we can write data. Here mass will be 0.4 kg. Amplitude will be 10 centimeter, means 10 into 10 to the power minus 2 meter, means 10 raised to minus 1 meter. Here potential energy at extreme position will be 1.97 into 10 raised to minus 2 joule, and we can find out time period. For finding time period, first we can find out omega. If we use the formula for potential energy is equal to half kx square of a particle performing linear S.H.M, which is also written as half m omega square x square. But at extreme position, X is equal to A. So potential energy becomes half m omega square A square. Means we can write as omega square is equal to 2 times potential energy divided by mass into amplitude square. If we substitute the values, 2 into 1.97 into 10 raised to minus 2 divided by mass will be 0.4 into 10 raised to minus 1 raised to 2. What happened? 2 1 the 2, 0.2 into 2 will be 0.4. So here decimal point is shifting, 1.97 into 10 raised to minus 2 divided by 2 into 10 raised to minus 1 into 10 raised to minus 2. 10 raised to minus 2 get cancel. So here 1.97 upon 2 into 10. So there division will be 0.9 because 9 to the 18, 1 is remaining, 8 to the 16, 1 is remaining, and 2 5 the 10 into 10. It will be 9.85 is the value of omega square. So by taking square root, therefore square root will be 9.85. Its square root 9.8 in 5 will be 3.139. We know that the formula for time period. So therefore time period is equal to 2 pi upon omega, which is 2 into 3.142 divided by 3.139, that is 4826 point divided by 3.139. If we take log, so log of numerator is 0 point characteristics, log of denominator is 0 point characteristics. So if we can see the log of 62 in 8, 4 is in mean difference, it will be 7983. Log of 31 in 3, 9 is in mean difference, it will be 4967. So subtraction, 6 is remaining, 1 is there, and 1 is remaining, 0 is remaining, 3 is remaining, and here 0 is remaining. By taking its antilog of 0.30 in 1, 9 is in mean difference, it will be time period is equal to 2.003 second. So it is the answer for given example. Again, if we solve another example, that is an object of mass 0.5 kg performs simple harmonic motion with force constant 10 Newton per meter and amplitude 3. So first we want to find its total energy, then we want to find maximum speed, then we want to find speed at x equal to 2 centimeter, and then we want to find kinetic energy, potential energy at 2 centimeter from its mean position. So first of all, by writing a data, mass will be 0.5 kg and force constant, that is m into omega square, it will be 10 Newton per meter, and amplitude is 3 centimeter. So we can find out first total energy. So total energy of object will be half m omega square A square, which is half k A square. If we substitute the value of k and a square, it will be half into 10 into 3 into 10 raised to minus 2 square, because centimeter is written as 3 into 10 raised to 2 minus 2 in meter. So it will be 2 1 the 2, 2 5 the 10. So 5 into 3 square will be 9 into 10 to the power minus 4. So total energy for the given example will be 45 into 10 raised to minus 4 joule. Second example will be what is maximum speed. So V maximum is equal to A omega, but we want to find omega. So by finding omega, we know that K is equal to m omega square. Therefore omega equal to square root of K upon m. By substituting the values, omega becomes square root of 10 upon 0.5. So here it will be 10 upon 5 into 10 raised to minus 1. By shifting 10 raised to minus 1 in numerator, it is square root of 100 upon 5 will be square root of 20. So if we substitute the value of square root of 20, then V maximum, it becomes amplitude will be 3 into 10 raised to minus 2 into square root of 20. So we know that square root of 20 is 4.472. So 3 into 4.472 into 10 raised to minus 2 will be 6. 21, 2 is remaining, 12, 14 is there, 1 is remaining, 12, 13. So it is 13.416 into 10 to the power minus 2. So it will be 1.3416 into 10 raised to minus 1, or 0.13416 meter per second. That is the maximum velocity. But third question will be, what is the speed at x equal to 2 centimeter? So speed is equal to omega square root of a square minus x square, which is square root of 20 multiplied by square root of a square is 9 into 10 raised to minus 4 minus x, that is 2 square or 4 into 10 raised to minus 4. So what happened? See here, square root of 20, it will be 4.472 multiplied by square root of 9 minus 4, 5 into 10 raised to minus 4. It will be 4.472 multiplied by square root of 5. It is 2.236 into 10 raised to minus 2. So here by seeing the logarithm 0.0, we can see logarithm of 44 in 7, 2 is in mean difference. So 44 in 7 will be 6503, and in 2 is mean difference 6505. Here 22 in 3, 3483, and 6 is in mean difference will be 12. So 85 and 10, 95, 3495. So it is 10, 10, 10, 10, 1 point. Antilog of 0.00 in 0. Antilog, it will be 1.000 into 10 raised to 1 into 10 raised to minus 2 meter per second, which is 0.1 meter per second. So velocity will be 0.1 meter per second. The third question. If fourth question will be there for finding kinetic energy and potential energy. So here first, kinetic energy is equal to omega square in bracket half m omega square in bracket a square minus x square. So here half multiplied by 0.5 multiplied by omega square, it will be 20 in bracket a square will be 9 into 10 raised to minus 4, 5 into 10 raised to minus 4. So here if we can divide 10 into 5, it will be 5 into 4 into 10 to the power minus 4. So sorry, here 2 is there, so 2 square will be 4 and 5 into 10 raised to minus 4. So it is 25 into 10 raised to minus 4 joule. It will be the kinetic energy. So kinetic energy is equal to 25 into 10 to the power minus 4 joule. And lastly, we have seen potential energy. So potential energy will be half kx square. Here k is given, that will be half into 10 x square. X will be 2. So 4 into 10 raised to minus 4. So what happened? 5. It also will be 20 into 10 to the power minus 4 joule. These are the answers for given. This assignment is solved for your practice.